This video lecture is going to cover the second half of Chapter 6, and we're talking about production costs and profit maximization. So the last lecture we discussed all of these terms, these first 6 or 7 here, and now we're going to talk about all different types of costs as well as different types of revenue, and then finally we're going to figure out how to determine a company's profit maximization point so that we can figure out at what price they should price their product and at what quantity they should be producing in order to maximize their profits. In order to figure out the profit maximizing point, there are 2 things we have left to discuss, which are the costs associated with inputs as well as the price associated with the output, so the price associated with what the product can be sold for. When we're considering costs, there are 2 different types of costs that go into creating a product. We have fixed costs and variable costs, and the sum of both of these, fixed costs plus variable costs, gives us our total cost. So how much it will cost in total to produce a particular product. So fixed costs are those costs that do not vary with the number of products that we are producing. So for example, there's a couple videos here that you're going to have to watch that are going to explain these concepts further, and in those videos they use the example of like a chocolate chip cookie factory. So a chocolate chip cookie factory, some examples of fixed costs is that building factory, whether they're making 200 cookies or 2,000 cookies, the fixed cost would be the costs of the electricity that it uses, to keep the lights on, potentially costs of rent of the building, cost of insurance of the building, and things that are going to stay constant no matter the number of cookies that are being produced. Variable costs are costs that are going to increase or decrease. They're going to vary, they're going to change depending on the level of cookies that are being produced and the inputs that are being used. So in the cookie example in the video, to make 2,000 cookies, variable cost, it's going to take more flour, more sugar, more butter. So variable costs would be those ingredients. And again, we already discussed fixed costs. So you're going to be responsible for clicking on these links. These links can also be found on your note sheet and answering the questions that are associated with those videos. Here's a snippet of the questions that you need to answer. Actually, it's not talking about cookies, it's talking about donuts. So go ahead and click on those links and answer those questions. As previously stated, the equation for total cost equals variable cost plus fixed costs. So it's the sum of both of those. So if we look at this graph over here, we have the total cost curve staying constant. It's staying at $100 no matter how much we're producing across the bottom here. We have the variable cost increasing as we produce more output, and then the total cost takes on the same exact shape as the total variable cost, but it is greater by the value of the total fixed cost. So if we look here at let's look at point C. So at an output of 4.8, our total variable cost is, here's our total variable cost curve. At 4.8, our total variable cost is $100. At 4.8, our total cost is $200. So that's a difference. It's greater by $100. And actually at every single point, it's greater by $100. That's because the value of the fixed cost is $100. So total fixed cost plus total variable cost equals total cost. We can also calculate the average cost per unit of output. So those totals that we were looking at, that's the total cost for any given number of output. So if we're producing 100 units, we were trying to figure out how much that costs total for all 100 units. When we're looking at average cost, we're trying to figure out how much it costs to produce 1 unit of product when we're looking at average. So we can calculate average fixed cost, average variable cost, and average total cost. So the questions that are answered when we're figuring out average fixed costs, for 1 unit of product, how much are we spending on fixed expenses? When we are calculating average variable costs, for 1 unit of product, how much are we spending on variable costs? And then for average total costs, for 1 unit of product, how much are we spending on both of those costs combined? So our equations to calculate average total cost, average fixed cost, and variable costs are given here, and it's just the total costs divided by the number of products that we are producing, or the output. So we can calculate average total cost, average fixed cost, and average variable cost if we are given the total fixed cost, the total average cost, or the total cost. Okay, so if we're going to calculate average fixed cost, so here is an example of, we've got our total output in units, so we're going from 1 unit all the way to 11.7 units. Well, we go to 12 at one point, and then production decreases. We have our total fixed cost, so fixed cost stays the same. Again, whether we're producing 1 unit or 12 units, total fixed cost is always $100. So to find the average fixed cost at each of those given points, we're just going to take the total fixed cost divided by the total output. So for this first one, it would be 100 divided by 1. So the average fixed cost is $100 because we're only producing 1 unit. For this second one, we have 100 divided by 3. So that's going to be 33.3. So our average fixed cost per 1 unit is $33. Then for the next one, we have 100 divided by 4.8. And that's going to be 20.8. The next one, we have 100 divided by 6.5, and that's going to be 15.4. So you can continue calculating those numbers down and fill that into your note sheet. So we can see that as we produce more units, the average fixed cost is decreasing. So we're able, the more units that we produce, we're able to spread that fixed cost over a larger number of products. And if our average fixed cost is decreasing, that is that's good, because it's costing us less per unit of product. And that's what that economies of scale term was referring to in the video and in the previous question. So if we're trying to figure out average variable cost over here, very similar way to calculate it, except we are taking total variable cost divided by the total output. So in this case, we have 50 divided by 1, because the total variable cost at this point is $50, divided by only 1 unit of output, so it's going to be 50. Our next one, we have 80 divided by 3, because at point B we're producing 3 units of output. So 80 divided by 3 is 26.7. Next one, we have 100 divided by 4.8. 100 divided by 4.8, and that's going to be 20.8. And we have 110 divided by 6.5, and that's going to be 16.9. Okay, so we can continue to calculate those numbers of average variable costs as we go down as well. So go ahead and complete those calculations and put those in your note sheet. Oh, and then we are going to calculate average total cost too. So average total cost is total cost divided by output, total output. So here we have the total cost, and again we have the total output over there. So we have total cost here, total output there. So in this case we have 150 divided by 1. So our total cost is going to be 150. That's a bad color to use. 150. Second one, we have 180 divided by 3. So our total cost there, let's see, 180 divided by 3 is going to be 60. And let's do one more. We have 200 divided by 4.8. It's going to be 41.7. Okay, so we can also see, so go ahead and calculate the rest of those, but we can also see that our average fixed cost plus our average variable cost is going to equal our average total cost. Just like our fixed cost, total fixed cost plus our total variable cost equals our total cost. Okay, so that's the relationship between those three. Another thing that we can calculate is the marginal cost. So marginal cost does tell us how much more will it cost us to produce one more unit of product at any given point. So to calculate the marginal cost is going to be different in between each of these points. And to calculate it, it's just going to be the change in total cost. Again, this triangle represents change in total cost divided by the change in output. And a change in total cost is going to be total cost 2 minus total cost 1 divided by output 2 minus output 1. Okay, so for each of these, we have our total costs here and our outputs here. So if we're going between A and B, our total cost 2 is 180. So we have 180 minus our total cost 1, which is 150, divided by our output 2, which is 3, minus our output 1, which is 1. Okay, so 180 minus 150 is 30. 3 minus 1 is 2. So in this case, our marginal cost is $15. So that means it, from points A to B, to increase our output by 1 unit, so to produce 1 more unit of product, it's going to cost us $15 more. Okay, so we can do the same thing from B to C. So let's erase this and let's look at B to C. So from B to C, we have our cost. Let's erase that too. Okay, so from B to C, so we have our output 2 as 2, or our total cost 2 as 200, our total cost 1 as 180, our output 2 as 4.8, and our output 1 as 3.0. 200 minus 180 is 20, 4.8 minus 3.0 is 1.8. 20 divided by 1.8 is 11.1. So our marginal cost from B to C is going to be $11.10. So it gets a little bit cheaper to produce 1 more unit when we're going from B to C than it was from A to B. So here's a completed chart. You can check your work and just make sure that you know how to calculate all of the average fixed cost, the average variable cost, the average total cost, and the marginal cost. And you can check your work with this chart. The data on this chart, so this is all of the data that we just looked at, can be put into a graph. And when we put that data into a graph, we can start to identify where the break-even point for a business would be when they're basically making the same amount of money that they are bringing in. So their costs are equal to their revenue. We can figure out where the break-even point is, and then we can also figure out where the shutdown point is. So the break-even point occurs when the marginal cost equals the average total cost. So if we look at the marginal cost curve, this is the marginal cost curve right here. And when that equals the average total cost, here's the average total cost right here, this is the break-even point. This means that at this point, and we follow it down, this would be the level of output, and if we follow it across, this would be the price of the product. So if we're charging $30 per product and we are producing, this is probably close to 10.2 units, then the firm is bringing in as much money as they are making by selling their product. Now, this makes sense because we will learn later how marginal revenue relates to this, that we're bringing in the same amount of money as it is costing us. The shutdown point, so SD, shutdown point, occurs, so a business should consider closing their doors and shutting down and stopping to produce their product at a point where the average variable cost, so this is the average variable cost curve, this green one here, is equal to the marginal cost. This is the point where the firm is only able to pay for their variable costs. They're not able to pay for any fixed costs, so they're actually short money, the difference between their total costs and their variable costs, which is their fixed costs. So when they're not able to pay for their fixed costs anymore, that's a point when the firm should shut down. Okay, so we've learned a little bit about cost, so we're one step closer to figuring out the profit maximization point for a company to help us determine at what quantity they should be producing and what price they should be charging in order to maximize their profits. A couple other things that we need to still look at to figure this out are the terms marginal revenue and average revenue. Marginal revenue is the amount of money or income that a business will gain from the production or sale of one more unit. So it answers the question, how much money will the business make by producing and selling one more unit of product? The equation to calculate marginal revenue is just the change in total revenue divided by the change in output. We'll practice that in a minute. Average revenue is the income that is the income per unit of output that a business receives for its products. So it answers the question, on average, how much money does the business make from each unit that it produces and sells? The equation is total revenue divided by total output. That should have total output there as well. So if we want to calculate the marginal revenue and the average revenue, we're just going to go ahead and look at these equations and do a few examples here. So the marginal revenue is the change in total revenue divided by the change in output. So again, we find this between 2 points. So we'll start by finding it between point A and point B. So the change in total revenue from point B between point A and B. So we're going to have total revenue 2 minus total revenue 1 divided by output 2 minus output 1. So total revenue 2, we'll say that that's B here. So total revenue 2 is 135. So we have 135 minus total revenue 1, which is 45, divided by output 2. Output 2 is 3 minus output 1, and output 1 is 1. So 135 minus 45 is 90, divided by 3 minus 1, which is 2. So that's going to be 45. So our marginal revenue here is going to be 45. So by selling one additional unit, we will make $45 more. Okay, let's do one more example. We'll go from B to C. So we have from B to C, so we have total revenue 2. Now our total revenue 2 is 216 minus our total revenue 1, which is 135, divided by our output 2, which is 4.8, and our output 1, which is 3.0. So 216 minus 135 is 216 minus 135 is 81, divided by 4.8 minus 3.0. 4.8 minus 3.0 is 1.8. So 81 divided by 1.8 is 45. So our marginal revenue again is 45. By producing and selling one more unit, we will make an additional $45. Now you can go ahead and calculate all the rest of those. What you are going to find though is they're all 45. That's not always going to be the case with marginal revenue, but if we look here at the market product price, it's $45 no matter how many units we are selling. This is only the case because we're operating in a perfectly competitive market, which we talked about at the beginning of chapter 6, which just means that producers are price takers, and the more or less that one firm or one business produces doesn't influence the market price. When we start to talk about scenarios that are not in perfectly competitive markets, the product market price will change with the more or less that is produced by that single firm. So in this case, these are going to be the same, okay? And then the average revenue for product, if we calculate those out, we're going to find something similar. So average revenue is going to be total revenue divided by output. So our total revenue is here, so $45 divided by 1 unit of output is going to be 45. So 45 divided by 1. Then we have 135 divided by 3. That's also going to be 45. 216 divided by 4.8 is going to be 45, all the way down to 526.50 divided by 11.7. 526.50 divided by 11.7 is also going to be 45. So all of these across the board are going to be 45. Again, that's because the product price is not changing with the amount that this single firm is producing. And that's because we're in a perfectly competitive market, but we'll see in future chapters different examples, and we'll see some of those values change. We touched base on this, but marginal revenue curve and average revenue curve will be perfectly flat and equal in perfect competition. So 45 straight across the board. This emphasizes the fact that a business in perfect competition is a price taker, and nothing it does can change the price of the market. So a single business does not have influence on market price. We can use the marginal revenue and the marginal cost to figure out the profit maximization point of a business. and also to figure out if a business is being profitable or not. So a business is profitable. We say that a business is profitable at the margin, meaning a business will be profitable if we add one more unit of production, add and sell one more unit of production, if the marginal revenue is greater than the marginal cost. So if the amount of money that we're going to bring in by making and selling the next product is greater than the amount that it will cost a business to make the next unit of product, then we're profitable. That makes sense. You're bringing in more than it's costing you. So when this is the case, the production should continue to expand. We should continue to produce more as long as marginal revenue is greater than marginal cost and until marginal revenue is equal to marginal cost. As soon as marginal cost is greater than or exceeds marginal revenue, then a business should not increase production because money is being lost. So when the production of one more unit costs more than we can sell that unit for, there's no profit, so production should stop. So we expand until marginal revenue equals marginal cost. So in this case, if we're looking at the marginal cost and revenue numbers over here, the profit maximizing point is going to be where marginal revenue equals marginal cost, which is going to be somewhere between point G and H. We'd have to graph this to figure out exactly where that would be, because we see 33 goes to 62 and we're looking for 45 to match 45 in there. So this is those numbers graphed. Okay, so we have the marginal cost curve, which is graphed right here, and we have the marginal revenue curve, which is graphed right here. So the point where these two meet is right at this green star, and that would be at output somewhere between 10.8 and 11.6. I would say, I don't know, maybe that's close to 11.0 or 11.2. I would say maybe 11.1. Okay, so let's say that's approximately at 11.1 units of output and at approximately $47. No, sorry, that's $45 because we were given that. The price is $45. So at the price of $45 and the output of approximately 11 would be the point where profit is maximized. And again, that's between point G and H. Profit maximization, again, occurs where marginal revenue equals marginal cost. That gives us the output. And also we're at market price there, $45. We can also figure out what the break-even price is and what the shutdown price for the business or firm is. So the break-even price is going to occur at the lowest point of the average total cost curve. So here's the lowest point of the average total cost curve. And if we follow that over to the price, looks like that's just under $30. At just under $30 and at an output of 9.6 units, that would be a break-even combination. So we would be making the same amount of money that it is costing us to produce, so there's no additional profit beyond that. The shutdown price occurs where the price equals the lowest point on the average variable cost curve. So the average variable cost curve, the lowest point is about right here, and we follow that over. That's our shutdown point. So it looks like that's probably about $16 or $17. So if the market price would fall to about $16 or $17, then this firm would decide to shut down, because at that point they are only meeting their variable costs with the amount of product that they're selling. So they're not able to pay any fixed costs. So at that point, they would shut down. Let's apply some of these concepts to practice problems, some questions here. So looking at the same graph, and given a couple equations here for profit and revenue. First one we've already answered, but we'll look at it again. Where does profit maximization occur on the graph below? Profit maximization occurs where marginal revenue curve meets the marginal cost curve. So what we'd be looking for there is it occurs at output or quantity. You can either do Q or quantity or output equals 11 and price equals $45. So when we're asking where it occurs, we're looking at what price and quantity that occurs at. What's the revenue, cost, and profit at this point? The revenue, given this equation, revenue equals quantity times price. So we're outputting 11 units, and we're charging $45. So the total revenue is 11 times 45, which equals $495. The costs at this point, let's just figure out total costs. It doesn't specify variable versus fixed, so we're going to look at total costs. So the total costs at this point, at 11 units of output, we have to locate our average total cost curve. So where the average total cost curve meets with 11 units of output is right here. So we follow that over. So our total costs are about $30. Okay, so 11 units times $30 is $330. And then profit equals revenue minus costs. So our revenue, profit equals $495 because that's our revenue minus our total costs, which is $330. So $495 minus $330 is $165. So that would be our profit at the profit maximizing point. If we are looking at the number 2, break-even point, so it says where does break-even point occur on this graph? Well, break-even point, we had found that in the previous example too, so that's where the lowest point of the average total cost curve meets the marginal cost curve. So here's our break-even point. So break-even point occurs at, we're going to say $30. So where price equals 30 and quantity produced equals 10. Okay, so where quantity produced or output equals 10 and price equals $30, that's where break-even occurs. What's the revenue, profit, and cost at this point? So revenue is going to be our quantity times price. So our quantity is 10 times our price, which is 30. So that's going to give us a revenue of $300. Our costs, total costs, are going to be the quantity times the cost. So the quantity that we're producing is 10. How much it is costing us? Well, we follow that up to meet the total cost curve. It's costing us $30, so our cost is $300. So our profit is revenue minus costs, 300 minus 300, which is $0, which makes perfect sense because break-even point should always be $0 profit. You're making as much as it is costing you to produce. Shutdown point occurs at the point where, let's erase some of this. Shutdown point occurs at the point on the graph where the average variable cost curve meets the marginal cost curve. Okay, so we have that here. Just for easy figuring, we're going to call that 9. And the price is, I'm going to say 16. So where does shutdown point occur? It occurs where Q equals 9 and price equals 16. What's the revenue at this point? Revenue equals quantity times price. So 9 times 16 is 144. The costs, total cost at this point, we're producing 9 and it's costing us, we have to follow this all the way up to the average total cost curve, which meets right here. So it's still costing us approximately $30 to produce a unit. So 9 times 30 is going to be $270 in costs. Profit equals revenue minus costs. So 144 minus 270 is negative 126. So we're losing money at this point. Negative $126. Okay, so revenue is, or the profit is negative, losing money. Okay, so that's how you would look at a graph and calculate some of those numbers. So let's see if our graph matches the math that we would do looking at this table. So we can calculate the profit at each of these points below by taking total revenue minus total costs. So go ahead and just calculate those out. Total revenue for point A, 45 minus 150. You know, we're going to be losing money there, so that's going to be negative 105. And calculate those out, and if you go ahead and do that, you're going to end up with these numbers, and we can see that our profit maximizing point is going to be somewhere in between G and H here, between 10.8 and 11.6, because we see we do go up to 186 and then we go down to 172. We could have gone up a little bit further before we went back down. So our profit maximizing point is somewhere between points G and H, and that is what we saw on our graph. Okay, so that just kind of helps us double check our work. So you have problems in your textbook number 3 and 4 that relate directly to some of the work that we did here. So I'm going to give you a couple hints. I'm not going to go through this whole problem, but I'm going to give you a couple hints here. So we need to find the shutdown point, and we need to know the quantity produced, the average total cost, the average variable cost, the total variable cost, and the profit at this point. Okay, so if you recall, the shutdown point is where the marginal cost curve meets the average variable cost curve. So for number 3, the quantity produced at this point is going to be 75. The price at this point is going to be $3. The average total cost at this point, you follow the 75 quantity all the way up to the average total cost curve where it meets. So that's going to be $5 per unit of average total cost. The average variable cost, you follow that up. So where 75 meets the average variable cost curve, which that's also the shutdown price, $3, right? So that is average variable cost is 3. The total cost, you follow that up to the total cost curve. Okay, so it's $5. So we don't have the total cost curve, sorry. Follow that up. So that's the average total cost. Average total cost per unit is $5, but we're producing how many units? So total cost equals quantity times average total cost. So we're producing 75 units, so total cost is going to be 75, and the average cost of each of those units is $5. So 75 times 5, let me calculate that real quick. 75 times 5 is $375. So that's our total cost. Our total variable cost is going to be the quantity times the average variable cost. So total variable cost, meaning for all 75 units, what's the variable cost? Well, it's $3 on average per individual unit, but we're producing 75 of those. So we have 75 times 3, which is $225. So that's going to be $225. And then what's our profit or loss at this point? So our profit or loss, well, profit, the equation for profit equals revenue minus costs. Well, we have not calculated the revenue yet, but we do know the total costs. So we do know we're going to subtract it from 375. Our revenue is going to be our quantity. Revenue equals quantity times price. So the quantity that we're producing is 75. And we're selling it for $3. So 75 times 3 is $225. So $225 is our revenue. So $225 minus $375. We're going to have a loss of $150. And that makes sense that we're going to have a loss because anytime we're at a shutdown point, we have a loss. Okay, so use those similar concepts to figure out number 4, your break-even point. That should already give you a clue. Break-even point, you should know what the profit and loss is going to be at break-even point. We talked about that on the previous slide. And then just make sure that you have values for every single thing that it's asking for on that problem. Okay. Here's another example problem that you'll come across in either the homework or the quiz questions. So we're given some input and output data, and we got to fill in some missing fixed costs and variable costs. So this company, is inputting 100 units, let's say, of labor here. On their first step, then they input 150 units. By increasing that labor, their output increases by 100 units. We need to know what happens to their total fixed costs, what happens to their total variable costs, what happens to their total costs, and we're given the marginal cost between those 2 points. So easy one to start with. We know that total fixed cost stays the same. Fixed cost stays the same no matter how many units we are outputting. So we can fill in 200 on the second line there. We know that total cost is equal to total fixed cost plus total variable cost. So 200 plus 1,000 is 1,200 for the total costs for this first output of 1,000. Now we need to figure out the total variable cost and the total costs for an output of 1,100. We know the marginal cost is 5, which means that it costs us $5 per unit to produce every additional unit from going from 1,000 to 1,100. So we're increasing our output here by 100, and each of those units is going to cost us an additional $5. So that's going to be an additional $500 that we are going to be adding to our total variable costs. We're not adding it to total fixed costs because fixed cost doesn't change, but we're adding $500 to total variable costs. So 1,000 plus 500, our total variable costs now increased to $1,500. So that would then increase our total costs as well. So 200 plus 1,500 is 1,700. 1,700 is going to be our total cost there. So this was the key piece here, knowing that it's going to cost us $5 for every single additional unit that we output, and we're outputting 100 more units, so 100 times 5 is 500. So that's going to increase our total variable cost by 500. The previous examples that we looked at dealt with profit maximizing output. So at what quantity and price should a business be producing in order to maximize profits? We can also figure out at what level of input should a company be operating at in order to maximize profit. So basically, how much, we've been talking about labor, so how much labor should they employ in order to maximize profits? So how we have a couple terms to look at to figure this out. First of all, the profit maximizing level of input occurs where marginal value product equals marginal input cost. We don't know what those terms are yet, so we'll figure those out in a second, but that's just like the profit maximizing level of output occurs where marginal revenue equals marginal cost, while the profit maximizing level of input occurs where marginal value product equals marginal input cost. So the marginal value of product is the amount of money in dollars that a business will gain by adding one more unit of input, in our case, labor, okay? So by adding one more unit of labor, how much money are we going to get from that? We'll look at an equation for that in just a little bit. The marginal input cost is the amount that it costs us to add one more unit of labor. This could be wage rate, for labor. So if it costs us $15 an hour to add one more unit, that could be our marginal input cost. We would not want, so in order to maximize our profits, we would not want the cost, how much it's going to cost us for that one more hour of labor, to be greater than the value that that one more hour of labor can produce for us. So that's why the profit maximizing point is where these two are equal. And then we can also calculate something called the marginal net benefit, which is just the difference between the two, the marginal value product minus the marginal input cost. The equation for marginal value product is this. Marginal value product equals marginal physical product. So let me write that out. Marginal physical product times product price. The marginal physical product is how much can we produce, how many units of output can we produce with one more unit of input. So increasing labor by 1 unit will give us how much more physical product, and whatever that is, we multiply that times the product price to figure out the value of that increased unit of input, in this case that increased unit of labor. Let's look at a couple examples. So if we have here, so we have several things going on in this chart. Our use of labor, so 10 units of labor, 16 units of labor, 20, 22, and we're continuing to increase our units of labor here. So they're saying with going from points A to B, 10 to 16 units of labor, each additional unit of labor is going to produce the marginal physical product 0.33, so 1/3 of a output for us. Each additional unit of labor is going to create 1/3 unit of physical product for us. Going from 16 to 20 hours of labor, we are going to have 45 100, so almost half a unit of product for every increased hour or unit of labor. Going from 20 to 22, we're going to have 0.85 physical products produced. So our marginal value product is our marginal physical product times the product price. And we're using the same example from previous examples where our product price is $45. So between A and B, our marginal physical product is 0.33, and we multiply that 0.33 times $45 to see what our marginal value of product is. So 0.33 times 45 gives us $14.80. So each additional hour of input that we hire will gain us $14.85 worth of product at the points in between A and B. Between B and C, it would be 0.45 times $45, which is $20.25. From C to D, it would be 0.85 times $45, and that's $38.22. Or 25 cents, sorry. So again, if we're adding 1 unit of labor, let's say 1 more hour of work, we are gaining at this point $38.25 worth of value in our product. So as long as we're paying them less than $38.25 per hour, then we would be making money, because our marginal net benefit is just the difference between the marginal value of product and the wage rate. So $14.85 minus $5 an hour, that's really cheap for a wage rate, but we are at $9.85 the company is making from that A to B point. When the marginal value product is $20.25 and you subtract the wage rate from that, the company is making $15.25. When it's at $38.25, the company is making $33.25 on each additional unit of labor or each additional hour that we are hiring somebody to work. So if you calculate all that out, we're going to see our marginal value product, increases up to a point, and then it starts to decrease. And our net benefit, we can see where our net benefit is increasing. So we're continuing to gain profit all through here until our wage rate is greater than our marginal value product. So until our wage rate, it's actually costing us more to hire somebody to work another hour than we are getting out of the value of the product that they are producing. So we can see that we peak here somewhere, in this GH range. Again, the profit maximizing level of input or of labor use occurs at the point where the marginal value product equals the wage rate. So it's going to be, we have 675 here and 360 here. So it's going to be between points G and H where that's going to actually equal $5. This is one of the quiz questions that you'll see this week, and the data on this graph is very close to the data on the chart on the previous slide, but it's actually just a little bit different. But again, the profit maximizing level will occur where marginal value product equals marginal input cost. So our marginal value product curve is posted here, and our marginal input cost curve is the same as the wage rate. So marginal input cost curve is the same as the wage rate because the cost of 1 more additional unit of input, in this case, is the cost of 1 more hour of labor. So where they meet, where they are equal, that is the input, the number of input hours, so in this case 40 hours of input, that would be our profit maximizing point. Because anytime the marginal value product is greater than the wage rate, so all of these points, the company is making money. As soon as the value that they're getting out of each additional hour of work is less than the wage rate, so underneath the curve, the company is losing money by continuing to hire more labor. So this question says, given the graph below, the area beneath the marginal value product curve and above the marginal input, that's what I have highlighted here in purple, represents the cumulative net benefit associated with the level of production. Yes, that is true, because the net benefit, remember, is marginal value product minus the wage rate, and that's going to give you the net benefit, or the, I'm not going to say profit, but the amount of money that they're making on each additional hour. Okay, so here's another question that we have. So assume that the price of sorghum is $6 per bushel when we apply 30 tons of fertilizer on our 20 acres of sorghum. The total yield is 1,000 bushels. When we apply 50 tons of fertilizer, the total yield is 1,500 bushels. What's the marginal value product per ton of fertilizer? Okay. Up to this point, we've only been talking about the input of labor. However, this problem is asking us to consider a different input. The input in this case we're being asked to consider is fertilizer. So we're going to use the same equation, but instead of labor, we're going to write fertilizer. Instead of labor, we're going to write fertilizer. Instead of labor, we're going to write fertilizer. Okay? So the question is asking us, what is the marginal value product per ton of fertilizer? So it's asking us to figure this part out, the marginal value product for fertilizer. To figure that out, we need to know the marginal physical price, or sorry, the marginal physical product and the product price. So let's see what information this problem gives us. It says, assume that the price of sorghum grain is $6 per bushel. Well, that's the product price given to us right there, $6. So our product price is $6 per bushel. Now we need to find the marginal physical product, which is saying how much more bushels of sorghum do we get by adding one more additional unit of fertilizer. I'm going to write that out. So in this case, our marginal physical product answers how much more bushels of sorghum do we get from adding one more unit of fertilizer. Okay, well, it tells us if we apply 30 tons, I'll change my color here. If we apply 30 tons of fertilizer, we get 1,000 bushels. If we apply 50 tons, we get 1,500 bushels. So our marginal physical product, we have an equation for that we learned earlier in chapter 6. Marginal physical product equals change in output divided by change in input. Our change in output, so if this is our change in output, we went from 1,500 bushel, or we went from 1,000 bushel to 1,500 bushel. So it's 1,500 minus 1,000, which is 500, right? Divided by our change in input. Our input went from 30 to 50. So 50 minus 30, which is 20. So 500 divided by 20, if I put that in the calculator quick, 500 divided by 20 is 25. So our marginal physical product is 25 bushels, which means that for each additional unit of fertilizer input, we will get 25 more bushels of sorghum. So that is our 25 bushels is our marginal physical product. So we have all the information we need. 25 times $6, because we're going to gain 25 more bushels of sorghum, and we're going to be able to sell that for $6. So 25 times 6 is $150 per ton of fertilizer. That's the value that we are going to get out of that fertilizer. We're going to get $150 per ton out of that fertilizer. So would it be valuable to increase our fertilizer application? Yes, it would be. That concludes our lecture for Chapter 6. Good luck with the quiz and the problems. And as always, email me if you have questions. Good luck.